Right now, every cell in your body is a battery. Tiny, living batteries, stacked by the trillions. It's not just chemistry. Voltage runs you. How does a cell become a battery? It builds a membrane, a thin lipid barrier, and places ion pumps and channels inside it. The star is the sodium-potassium pump. It burns ATP to move ions, sodium out to potassium in. That imbalance creates an electrical charge across the membrane. Inside becomes negative relative to outside. That's your resting membrane potential. Neurons use that voltage like a telegraph line. When channels open, ions rush, the voltage flips, and an action potential fires. That spike zips down the axon. Thoughts, movement, memory, all riding on voltage waves. But it's not just neurons. Muscle cells use voltage to trigger contraction. Heart cells pace themselves with rhythmic electricity. Pancreatic cells release insulin when their voltage changes. Even immune cells modulate behavior with ion flows. Voltage is a universal language inside you. Zoom out, tissues have bioelectric patterns. Sheets of cells can hold different voltages, forming electrical maps. During wound healing, damaged skin creates a local electric field. Cells read that field like a compass and migrate to close the gap. In development, bioelectric cues help cells decide where to grow, what to become, and when to stop. We're not just chemistry in a bag. We're circuits with structure. What happens when voltage goes wrong? If cells become depolarized, less negative inside, they can shift identity and behavior. In research, abnormal bioelectric states are linked to uncontrolled growth and tumor-like behavior. Flip side, restoring healthy voltage patterns can normalize some cell behaviors and models. Bioelectricity isn't magic, but it's powerful control data for biology. Everyday examples you can feel: pins and needles after your foot falls asleep? Ion gradients disrupted, channels misfire, weird signals. Electrolytes after sweating? You're literally rebuilding the ion balance your cells need to keep their voltage stable. ECG, EEG at the hospital? Those machines are reading bioelectric fields from heart and brain. Let's get a little quantitative. A typical resting neuron sits around 70 millivolts. That sounds tiny, until you remember the membrane is nanometers thin. The electric field across it is enormous, comparable to thundercloud fields packed into microscopic space. Your body is a quiet lightning storm. Organized. Precise. Constant. Myths, quickly. Electric equals dangerous. Your bioelectricity is low voltage, high control. It's how signals route, not a shock hazard. Only nerves are electrical. Nope. Most cell types use membrane voltage for decisions. It's all chemistry anyway. Chemistry creates the gradients, electricity carries the information. Can you boost your internal batteries? Think foundations, not gimmicks. Electrolytes, sodium, potassium, magnesium, especially with sweat loss. Sleep, ion gradients reset, pumps catch up, brain cleanse house. Movement, improves circulation, pH balance, and channel function. Nutrition, enough protein for pumps, channels, micronutrients for ATP production. Stress management, hormones and pH shifts can alter channel behavior. No fancy hacks required. Just support the hardware. Future tech? Scientists are exploring bioelectric therapies, using gentle fields or targeted ion channel drugs to guide wound healing, modulate pain, and influence regeneration. Imagine medicine that edits electrical patterns to steer cells, like reprogramming a circuit. Recap. Every cell maintains a voltage with pumps and channels. Neurons, muscles, glands all signal with ion flows. Tissues carry bioelectric maps that guide healing and growth. Healthy voltage equals coherent signals, disturbed voltage equals confused biology. Sleep, electrolytes, movement, and nutrition keep the battery steady. You're not just chemistry. You're electrical by design. Love clear, reality-bending biology? Subscribe. New long-form curiosity every Sunday.